Hello and welcome to this video on numerical differentiation using the finite difference method. So this is the second video. To watch the introductory video, do where to look at the description of this video and you will find a link to that amazing video. So in this video, we're going to be considering this question, and it says, for the following table of values of x and y, obtain the y dx and the squared y dx squared for x equals 1.2. All right, so basically we are asked to find the first derivative and second derivative approximation for this given table of values. Now we're asked to do this when x is equal to 1.2. So the first thing to do is to know which of the method to use. In the previous video, I explained that we have three types of finite difference method. We have the forward difference method, we have the backward difference method, and we have the central difference method. Now we are asked to approximate the first derivative and the second derivative when x is equal to 1.2. So the first thing to do is to find what part of the table does x lie. If it lies at the forward table, it means we are going to be using the forward difference approximation method. If 1.2 lies at the back of the table, it means we are going to be using the backward difference approximation method. But if it lies somewhere between the middle of the table, it means we are going to be using the central difference method. Okay. Now, how do you know which is your forward table and which is your backward table? Simply, excluding this table of x and y, let's now consider the table of real values. Okay, we have here 1, 2, 3, 4, 5, 6, 7 columns has real values here. So which means the middle of this table becomes 1, 2, 3, 4. This becomes the middle of the table. So from here to this point is the middle of the table. Now the table of values from the beginning of the table to the center is called the forward table, and the table of value from the center to the end of the table is called the backward table. So if the value of x upon which you're to carry out the approximation of these derivatives lie at the forward of the table, then it means you will employ the forward difference method. But if the value lies at the end of the table or back of the table, you will use the backward difference method. If it lies at the center, then you use the central difference method. In this case, we are asked to approximate these derivatives when x is equal to 1.2. So you find out that 1.2 lies actually here, which is at the forward of the table. This simply means we are going to be employing the forward difference method to carry out the approximation of these derivatives. Now, by formula, the forward difference method for the first derivative is given as f prime of x equals f of x plus h minus f of x all over h. So what then is h? H is simply known as our interval. An interval simply means difference in the values of x. Okay. So let's obtain our interval now. Our interval becomes interval h is going to be either x1 minus x0 or x2 minus x1 or x3 minus x2 and so on. So we can simply pick x1 minus x0, which is 1.2 minus 1.0. So h equals 1.2 minus 1.0. So this simply implies that our interval h is equal to 0.2. So you see, our h is obtained here as 0.2. So if we know the value of h as 0.2, then we need to now find these functions. X is the value that is given to us upon which we want to approximate these derivatives. And x is given as what? X is equal to 1.2. So from this formula, we find first f of x plus h. So we find f of x plus h. That is going to be equal to f of x is 1.2 plus h is 0.2. So this simply implies that f of x plus h is going to be equal to 1.2 plus 0.2. This gives us f of 1.4. So you keep this. So this simply means f of x plus h is f of 1.4. Now again, f of x. This f of x simply means f of x itself is a point of interest, and x there is 1.2. So f of x there becomes f of 1.2, and you have this. So having known these values now, we now plug this into this equation. Let's do this and see. This means that the first derivative become f of x plus h, and f of x plus h simply gives us f of 1.4. So we have f of 1.4 minus f of 1.2. Okay, this divides by h. So this is going to be equal to, now you look through the table. If you look through the table, you find the value of f of 1.4 from the table. From the table, when x is 1.4, the value of f was given here as 4.0552. When x is 1.4, the value of y, or f of x, gives us here 4.0552. That means f of 1.4 is actually 4.0552. So you put it down, 4.0552 minus f of 1.2. So when x is 1.2, the value of y, which is f of x, simply is 3.3201 from the table. Okay, when x is 1.2, y is 3.3201. So this becomes minus 3.3201, 3.3201 divides by h, and h is the interval. We obtained the interval earlier as 0.2. So divide by 0.2. Okay, so this simply implies f prime of x, which is your first derivative, becomes, now let's find 4.0552 minus 3.3201. So that difference gives us 0.7351 divided by h, and h is 0.2. Now this simply implies that the approximate value of the first derivative of that function becomes, now divide this by 0.2. That gives us approximately 3.6755. So this becomes the first derivative approximation of the function when x is equal to 1.2. Now, the next question says we should also approximate the second derivative. So you recall the second derivative approximation value. Okay, we stated all of this in the first video. So to watch the first video, do well to follow the link at the description of this video. Okay. So for the second derivative, you have f prime prime of x is equal to, we simply obtain f of x plus 2h minus 2f of x plus h plus f of x all over h squared. So this is the case of the forward difference method. So if it is backward, the formula will be different. Again, please do well to watch the previous video. Link of that video is in the description of this video, and then you'll get the formulas to all of these methods. All right. Now we know what now we need to find f of x plus 2h, and we need to find, we already know what f of x plus h is. We know what f of x is. Let's now find f of x plus 2h, then couple back into this formula. Okay, so we find f of x plus 2h, right? So we find f of x. Okay, let me just let me highlight here. So we find f of x plus 2h. So this is going to be equal to, this will be f of x itself is 1.2, the point of interest, plus 2h means 2 times the interval, and interval h will obtain the value to be 0.2. So you have 2 times 0.2. Okay, so f of x plus 2h, f of x plus 2h is now going to be equal to 2 times 0.2 is 0.4 plus 1.2. That simply gives us 1.6. So f of x plus 2h is simply what? F of 1.6. So you keep this aside. Okay, now let's plug this whole value into this formula. Okay, so the double derivative f prime prime of x is now going to be equal to, now f of x plus 2h is simply what? F of 1.6 minus 2 times, we already obtained f of x plus h earlier, and we had f of x plus h to be f of 1.4. Okay, so minus 2 times f of 1.4, okay, plus f of x, and x itself, which is the point of interest, is 1.2, so it becomes plus f of 1.2, and you have this. The whole of this divides by h squared, which is the interval, divides by h squared. Okay, so once more, we fall back now to the table. We need to find f of 1.6. We know what f of 1.4 is, and we know what f of 1.2 is. Now let's find f of 1.6 from the table. So let's fall back now to the table. Now when x is 1.6, we have the value of f of x, which is same thing as y, to be 4.9530. Okay, so when x is 1.6, y is 4.9530. We already know the value of f of 1.4. This is giving us 4.0552. So when x is 1.4, y is 4.0552. And we also know when x is 1.2, the value of y to be equal to 3.3201, as can be seen from the table. So we plug all of this now into the equation. So this is now equal to, we said f of 1.6 and f of 1.6, we obtain the value to be 4.9530. So we have 4.9530. Now here is minus 2 times f of 1.4. So you have minus 2 times f of 1.4 itself gave us simply 4.0552. So minus 2 times 4.0552 multiplied by plus f of x, and f of x when x is 1.2 plus f of 1.2, and f of 1.2 simply gives us 3.3201. So you simply add plus 3.3201. Now divide this by the square of the interval. Interval is 0.2, all squared. Okay, so this simply implies that the double derivative f of f prime prime of x is going to be equal to, so let's evaluate everything at the numerator. Okay, so we have 4.9530 minus, let's obtain 2 multiplies 4.0552. That gives us 8.1104 plus, we have 3.3201 all over 0.2 squared. That simply gives us 0.04 all over 0.04. So this is going to be equal to, let's evaluate the numerator altogether. So we have 4.9530 minus 8.1104 plus 3.3201. So this simply gives us 0.1627 divides 0.04. So this simply implies that the double derivative f prime prime of x is going to be equal to, divide this answer by 0.04. That gives us approximately 4.0675. Okay. So this becomes the approximate value of the double derivative of that function. Okay, so that's how to employ the forward difference method to solve numerical differentiation problem. In the subsequent videos, we are going to be looking at the backward difference method and the central difference method of solving numerical differentiation problems. I am sure you want to be a part of that video, so do well to smash the subscribe button right now and turn on your notification bell so you don't miss out on the updates when those videos drop. In the meantime, do well to like this video, comment nicely, share to your friends and colleagues, and if you are new to the channel, do well to hit the subscribe button. I will see you in the next video. Thanks.